Ever click a button on an app and just marvel at how many things seem to happen instantly, behind the scenes?
Yeah, like payments getting processed, inventories updated, maybe notifications firing off.
Exactly. It's like this digital ballet of interconnected parts. But trying to figure out how all those parts actually communicate, that can feel like, I don't know, trying to understand a giant invisible machine. So many moving pieces.
That feeling, trying to untangle a complex web. It's spot on. And, well, it's exactly why something called service-oriented architecture, or SOA, came about.
SOA.
Think of SOA as a way to bring some structure to all that complexity, organizing those interconnected systems into more manageable, sort of independent units that can, talk to each other.
Yay. SOA, service-oriented architecture. So instead of one giant monolithic program, it's more like a collection of smaller programs, services working together.
That's the idea.
What's the real advantage of setting things up like that for us or for the developers?
Well, the big wins are agility and flexibility, definitely. Let's say you need to tweak a specific function, maybe how you handle shipping calculations.
Right.
With SOA, you can update just that shipping service without having to rewrite and redeploy the entire application. It's like upgrading just one tool in your workshop instead of, rebuilding the whole shed.
That makes sense.
And this modularity, it doesn't just allow for quicker updates to individual parts, it also really significantly reduces the risk when you make those changes.
How so?
Well, think about it. A bug in the shipping service, for instance, is much less likely to bring down the entire e-commerce platform in an SOA setup compared to, like, a monolithic one where everything's tangled together.
Okay, yeah, I can see that. Less risky.
Right. And that translates to faster development cycles, more confidence in deploying new features, faster iterations.
So these services you mentioned, they're more than just like snippets of code then. Are they actual business functions?
Precisely. A service in SOA is a reusable unit, and it performs a specific business function. Think back to that shipping service example.
Okay.
It's not just code. It handles the whole business process of calculating shipping costs. An online store can request this service, give it the delivery details.
And it sends back the cost.
Exactly. The service calculates the cost and sends back a response.
Got it. But how do these services actually talk to each other? Especially if they're, across the internet, not on the same computer.
Yeah, that's where web services come into play. These are essentially independent software components that are accessible over the internet.
Okay.
You have a service provider, that's the one offering the service. They make it available online. It's almost like listing a business in a directory, often done through something called a web service registry.
A registry, like a phone book for services.
Sort of, yeah. A client who needs that service, like our online store needing the shipping calculation, can search this registry. Once it finds the service, the registry gives the client a couple of key things. First, a URL, the service's web address.
Oh, the address.
And second, something called a WSDL. Think of the WSDL as a really detailed instruction manual for the service.
An instruction manual.
Yeah, it tells any other program exactly what kind of information the service needs to do its job and what kind of information it's going to send back, like a restaurant menu with descriptions of all the dishes.
Okay, so the client has the address and the manual, the WSDL.
Yeah.
How does the actual conversation happen when they want to use the service?
They communicate through messages, often using a standard format called SOAP, that stands for Simple Object Access Protocol.
SOAP, okay.
These SOAP messages are like the actual order you place at the restaurant. They contain all the necessary details, and they're usually sent over the same internet highway, HTTP, that your web browser uses.
So standard web stuff.
Pretty much. The client sends a SOAP message with its request to the provider's URL, and the provider sends back another SOAP message with the response.
You mentioned a weather report example earlier. How does that fit into this? How does it show services working together?
Yeah, that's a perfect real-world example. Think about it. Instead of every single website or app having to build its own complex weather forecasting system from scratch.
Which would be crazy inefficient.
Totally. They can just tap into a specialized weather report service, maybe provided by a big weather data company.
Right.
This service, once you connect to it, can then display the latest weather info on countless different websites, apps, you name it. It's just much more efficient than everyone reinventing the wheel.
Okay, that makes a lot of sense. So we have these services, they're talking to each other using things like SOAP and WSDL. Now, when we need to make sure everything in this interconnected web is actually working correctly, Where do we even start with testing all this? It sounds complicated.
It can be, yeah. But in SOA, we typically look at the system through, let's say, 3 lenses or layers, and testing is really vital at each one.
3 layers.
Right. These are generally called the services layer, the process layer, and the consumer layer.
Okay, services, process, consumer. Let's dive into those. What's happening at the services layer?
So the services layer is basically where the individual services themselves live, those building blocks we were talking about.
The core units.
Exactly. These are the core business functionalities, but broken down into independent units. Remember that wellness website example,
Sure.
vaguely? Yeah, remind me. You might have separate services for, say, tracking weight, another for blood sugar, maybe another for blood pressure, and definitely a login service. Each one is responsible for managing its specific bit of data, probably in a database somewhere.
Okay.
So testing at this level, the services layer, is all about making sure each individual service works exactly as it should, kind of in isolation.
Got it. Testing each building block on its own first. Makes sense. What about the next layer up, the process layer?
The process layer is where you start seeing those individual services coming together, working together to perform a larger task.
Integration.
Essentially, yeah. It's a collection of services orchestrated to achieve a specific business process. A search engine is a pretty good example. It uses various underlying services, right, to process your query, find results, rank them, display them.
Right.
Or think about an online checkout process. That might involve a service to verify your payment, another to check inventory, maybe another one to generate the order confirmation.
Lots of services working in sequence.
Exactly. So at this layer, testing focuses on how well these services integrate and work together, and also on any user interfaces that might directly interact with these combined processes.
Okay.
For our weight tracker service from the wellness site, this layer might involve testing the actual screen where someone enters their weight. We'd need to ensure that UI correctly calls the underlying weight tracker service and, crucially, that the data gets saved properly.
So we're looking at how the individual services play together and how users interact with those combined processes. Got it. That leaves the consumer layer. What's that?
Exactly. The consumer layer is primarily what the end user actually sees and interacts with.
The app itself, the website.
Yeah. The websites, the mobile apps, maybe desktop applications, whatever, provides the access to the whole SOA-based system. Testing here really focuses on the overall user experience. How smoothly do the integrated services function from the user's point of view? Does it feel seamless?
Okay, so we have these 3 layers: services, process, consumer. When we actually get down to the business of testing, does this layered structure kind of dictate how we approach it? Are there specific levels of testing we should be thinking about?
Absolutely. Based on those layers, we generally talk about 3 main levels of SOA testing. There's service level testing, interface level testing, and end-to-end level testing.
Service, interface, end-to-end. Okay.
And there's a common pattern for how we approach this. When we're planning our testing, designing the tests, we often use a top-down approach.
Top-down, meaning?
Meaning we start with the big picture, the overall business goals, the user journeys, and then break those down into the individual services and interactions that need to work together to achieve them.
Okay, start high level, then get specific for planning.
Right. But interestingly, when it comes to actually running the tests, executing them, we typically flip that. We use a bottom-up approach.
So start small.
Exactly. Start by testing the individual services first. Make sure each building block is solid on its own. Then test how they interact at the interfaces. And finally, test the entire system flow from end to end.
Top-down design, bottom-up execution. Oh, okay, I think I get that. It seems logical for building confidence in the system piece by piece. So what are some of the key strategies and methods we actually use to do this SOA testing?
Well, a solid test planning approach is absolutely fundamental. You can't just jump in.
Right. What does that involve?
First, you really need a deep understanding of the entire application architecture. How do all the different services connect? What are the dependencies? You need that map.
Okay. Understand the whole picture.
Then you break down the application into those individual independent services we talked about. Carefully examine their inputs, their outputs, what they're supposed to do.
Analyze the components.
Right. It's often helpful to think about the system in terms of its core parts. You've got the data, you've got the services that manipulate that data, and you've got the front-end applications that let users interact with it all.
Data, services, front end. Yeah.
Next, you analyze all these pieces and you create detailed business scenarios. Think about how people will actually use this thing. You need both the common, everyday uses.
Like placing a standard order?
Exactly. And also the more specific, maybe edge case scenarios. What happens if something goes wrong? What are the less common paths?
Cover all the bases.
You try to, yeah. And finally, a crucial step is creating a traceability matrix.
A traceability matrix. Sounds formal.
It is a bit, but it's incredibly useful. It's basically like a map that links every single test case you plan to run back to a specific business requirement or scenario.
Ah, so you know why you're running each test.
Precisely. It ensures your testing efforts are focused on what actually matters for the business and that you have coverage for your requirements.
Okay, that's the planning, the blueprint. What about actually putting those plans into action? Running the tests, the execution phase.
For test execution, as we said, we generally follow that bottom-up approach.
Start with the services.
Right. We start by thoroughly testing each individual service component in isolation. Does it work correctly on its own? Does it handle good data, bad data?
Verify the building blocks.
Then we move up to integration testing. This is where we verify that data flows correctly between the different services. Does the output of one service work as the input for the next? Does the data stay accurate as it moves through the system? Data integrity is key here.
Making sure they talk correctly.
Exactly. After that, we conduct system testing of the complete model. This is broader, making sure data flows seamlessly all the way from the user interface through the services down to the underlying databases, and then back again if necessary.
The whole chain.
The whole chain. And finally, performance testing. This is crucial. We need to identify any bottlenecks, make sure the system can handle the expected load, and ensure it performs efficiently. No one likes a slow app.
Definitely not. Okay, you mentioned specific testing methods earlier. What are some of the go-to techniques testers use in the SOA world?
Yeah, there are several important techniques we rely on. One key one is business scenario-driven database testing.
That sounds like a mouthful. Break it down.
It basically means we really focus on how the application is used in a real business context. Not just technically, but functionally from a business perspective.
Okay.
We develop test scenarios based on how the web services and the overall application need to integrate to fulfill a business process, like processing an order or updating a user profile. And then we set up test data that covers those complete end-to-end business processes.
So testing in the context of real-world business use, not just isolated functions.
Exactly. It makes the testing much more relevant. Another key method involves using stubs.
Stubs, what are those?
Think of stubs as temporary stand-ins, dummy interfaces for real services that our system depends on.
Like a placeholder.
Kind of, yeah. This is super useful if a service we need to interact with isn't ready yet during development, or maybe if it's a third-party service like a credit card processor that we can't or don't want to hit directly during our tests.
Ah, okay. So you can test your part even if the other part isn't available.
Precisely. We can program these stubs to provide specific, predictable responses back to our service that's under test. This lets us verify that our service interacts correctly, that it sends the right data and handles the responses properly without needing the real service to be live and functional.
So it's like having a practice partner for our service. Lets you test its moves before the real game.
That's a great way to put it, exactly. Then, of course, there's regression testing.
That sounds familiar. Testing things haven't broken after a change.
That's it. And it's absolutely vital in SOA environments because individual services might be updated or changed quite frequently, maybe by different teams even.
Right, because they're independent.
Exactly. So after any modification to a service, or maybe even related services, we need to run a comprehensive suite of existing tests to make sure that the changes haven't unintentionally broken any existing functionality elsewhere in the system. It ensures stability.
Makes sense. What else?
Well, we already touched on service-level testing. Again, that's testing each individual service for its core functionality, its security, its performance, and also how well it interoperates, speaks the right language to potentially connect with other systems.
Yeah, the individual block check.
And closely related is functional testing at the service level. This is really about the nitty-gritty. Does the service deliver the correct output for various inputs? Does it handle incorrect or unexpected data gracefully? Does it return the right error messages when something goes wrong? And are the responses it sends back in the expected format and correct?
Checking all the details of the service's behavior.
Okay. You mentioned security earlier, too. That must be huge with all these things talking to each other. Oh, security testing is absolutely critical in SOA, hugely important. Because you have services communicating, often over networks, sharing data, There are many potential points of vulnerability.
So what do you look for?
We need to verify that the application adheres to relevant security standards, like WS security is a common one for web services. We need to ensure strong security measures are actually implemented, things like data encryption for sensitive information, digital signatures maybe to verify message origins.
Authentication, too, like login.
Definitely user authentication, proving who you are, and authorization checking what you're allowed to do need to work correctly and consistently across all the services involved in the process. And then there's testing for common web vulnerabilities.
Like hacking attempts.
Sort of, yeah. Things like SQL injection, where someone tries to trick your database, malware protection, cross-site scripting, or XSS, cross-site request forgery, CSRF, and of course, denial of service attacks, trying to overwhelm the service so it can't respond. We have to actively test for those.
Wow, yeah, security is a big domain in itself. What about performance? You mentioned services might be reused a lot.
That's right. Performance testing is another crucial one. Because a single service might be used by many different applications or processes, the load on it can be significant and sometimes unpredictable.
So you need to make sure it can handle the traffic.
Exactly. We need to test the performance of each service on its own, but also, importantly, how it performs when it's integrated and interacting with other services. Sometimes the interaction itself causes bottlenecks.
What are you measuring? Speed?
Primarily, yes. Response times under various load conditions. We also monitor resource usage, how much CPU and memory is it consuming. We look for bottlenecks. And we assess scalability, how well does the service perform as the load increases. Can we just add more resources to handle more traffic?
Okay. And making sure they all play nicely together, that integration piece seems key.
It really is. Integration level testing specifically focuses on those communication pathways, the interfaces between the coupled components.
The connections.
Right. Here, we're not just concerned with whether each service works individually, but critically, do they exchange data correctly and consistently? We run tests that cover the key business scenarios that involve multiple services interacting. And non-functional testing, like security and performance, often gets revisited at this integration level too, because the interaction might introduce new issues.
Okay, so service level, then integration level. What's the final one?
The final one is end-to-end testing. This is the big picture view.
Simulating a real user doing something from start to finish.
That's exactly it. End-to-end tests simulate complete user journeys through the application. The goal here is to ensure that the entire integrated system meets the overall business requirements. Both functional requirements, does it do what it's supposed to do, and non-functional ones, is it fast enough, is it secure?
What kinds of things are you checking in end to end?
We're testing how the system handles errors or exceptions that might occur during a long workflow. We're looking at the user interface, of course. We're verifying the complete flows data through multiple services and systems. And we're validating that the overall business processes are completed correctly.
It sounds like a really thorough, multi-layered approach. But I imagine with all these different layers, interactions, dependencies, there must be some unique challenges that come specifically with testing SOA applications.
You're absolutely right. It's definitely not without its difficulties. There are several inherent challenges.
Like what? What are the main headaches?
Well, for one, sometimes individual services, especially lower-level ones, don't have a direct user interface. That can make them harder to test directly, which is why tools and stubs become so important.
Okay, lack of UI for some services. What else?
Because testing often involves interactions across multiple different systems, maybe even systems owned by different teams or third parties, just setting up and managing all the necessary test data can become really quite complex. You need the right data in the right places at the right time.
Data management gets tricky.
Yeah. Another big one is the rate of change. The fact that individual services can be updated frequently, independently, well, it means you need to run regression testing much more often to catch problems. And that can become a significant ongoing effort and cost.
Constant retesting.
Pretty much. Also, if something does go wrong, pinpointing the exact service or interaction that's causing the defect can be tricky. Because of the multi-layer architecture, a failure might cascade, and the root cause might be hidden several layers deep. Debugging can be tough.
Hard to isolate the fault.
It can be. Predicting load for performance testing is another challenge. Because a service might be reused by many different applications in unpredictable ways, figuring out realistic peak load scenarios can be difficult.
Hard to know how popular it will be.
Something like that, yeah. And because SOA often involves a mix of different technologies, maybe some Java services, some .NET, different databases, messaging systems, you often need a testing team with a really broad range of technical skills. That diversity can increase planning time and execution
Need
costs.
more specialists.
Potentially, yes. And one more specific challenge, security testing. Ensuring consistent security, especially things like authentication and authorization, across multiple and created services that might have different security models. That can be a significant hurdle to get right.
Those are definitely some significant hurdles to overcome. Thankfully, I assume there are tools available to help testers tackle these SOA-specific challenges, right?
Absolutely. Yeah, thankfully the tooling has matured quite a bit. There's a range of tools out there specifically designed to assist with various aspects of SOA testing. They can make a huge difference.
Like what? Can you give us some examples? What are some of the popular tools testers might use in this space?
Sure. One very popular one, especially because it has a good free open source version, is SAP
SAPUI.
It's a desktop application, and it's really versatile. It supports a wide variety of protocols, not just SA, but also REST, plain HTTP, JMS for messaging, even database connections via JDBC.
So it handles lots of different service types.
It does. You can use it to basically build, inspect, and run web service calls manually. But it also has strong capabilities for test automation, load testing, and even security scanning for common vulnerabilities.
Automation and load testing, that's useful.
Definitely. And a particularly useful feature we talked about earlier is its ability to create stubs, they call them mock services, in SOPUI. It lets you simulate the behavior of other services your service depends on.
Right, the stand-ins.
Exactly. It can also automatically generate basic test structures from a web service definition, like a WSDL, and it provides built-in reporting. It's developed by a company called SmartBear.
Okay, SOAPUI sounds like a pretty handy, almost like a Swiss Army knife for web service testing. What's another one people might use?
Another comprehensive suite, maybe geared a bit more towards enterprise environments, is ITKO LISA. Well, it's now part of CA Technologies, or Broadcom, I think.
LISA.
Okay. It really focuses on functional testing for complex distributed systems, exactly like those built with SOA. But it also extends into regression testing, integration testing, load testing, and performance testing. It provides a whole platform for designing and executing these complex tests.
So more of an integrated platform.
Yes, a commercial suite. Another enterprise-focused option is HP Service Test, which is now part of Micro Focus.
HP Service Test.
This is primarily a functional testing tool, but it's designed to support testing of both the user interfaces and the underlying shared services. A key benefit often touted is that you can sometimes use the same test scripts for both functional validation and performance testing, which can save effort.
Reusing test scripts sounds efficient.
It can be. It also typically integrates well with other tools in their quality management ecosystem, like HP Quality Center, ALM, and it's designed to handle scenarios with large numbers of services and complex test data. It also has features specifically aimed at helping with interoperability testing, simulating different types of client applications interacting with your services.
Okay, another enterprise player. Give us one more example, maybe something different.
Certainly. Parasoft SOAcast is another strong contender in this space.
Parasoft SOS.
Right. It's positioned as a testing and analysis tool suite specifically for APIs and API-driven applications, which includes SOA, of course. It supports a very wide range of technologies, web services, REST, JSON, various messaging systems like MQ, JMS, TBCO, plain HTTP, XML, you name it.
Broad technology support.
Very broad. It enables a whole spectrum of testing types. Functional, unit testing at the service level, integration, regression, security, interoperability, even compliance testing against standards, and performance testing.
Compliance testing, interesting.
Yeah. And one of their notable features is intelligent stub creation through a companion product called Parasoft Virtualize. It aims to create more realistic, data-driven simulations of dependent services compared to simpler stubs.
Smarter stubs.
Yeah.
Okay, so it seems like having the right tools, whether open source like SOA PUI or a commercial suite, can definitely make a big difference in managing the complexity and effectiveness of SOA testing.
Absolutely essential, I'd say.
Let's try to bring all this together now. Can we walk through a kind of real-world example, maybe that e-commerce website we keep mentioning? How would we actually apply all these SOA testing principles and phases to something like that?
Yeah, that's a great idea. It helps make it concrete.
Yeah.
Okay, so imagine our e-commerce site. It has core functions, right? Let's focus on one key function, like order processing.
Okay, processing an order.
In the first phase, the test strategy phase, we'd start by breaking down that whole order processing flow into its constituent services. What are the smaller independent parts?
Like what might those be?
Well, we might identify services like create order, maybe check customer status, change order status, check order status, definitely something like check inventory.
Oh, yeah, breaking it down into service units.
Right. Our task strategy document would then list out all these services, describe what they do, and outline the overall business function, order processing that they support. It sets the scope.
Okay, strategy defined, scope set. What happens in the next phase, test planning?
In the test planning phase, we get more detailed. We start writing specific test cases, but we think about them at those different levels we discussed: end-to-end, integration, and service level.
Right, the 3 levels. Give me some examples.
Okay, for end-to-end level, we'd create scenarios that mimic real user actions from start to finish. For instance, a registered active user successfully places a new order for an in-stock item. Or maybe a user tries to place an order for an item that just went out of stock, verify the error handling, or a user successfully cancels a recently placed order before it ships.
Full user journeys. Okay,
Yeah.
what about integration level?
For integration level, we'd focus on verifying the communication and data consistency between those services. Examples might be: when a new order is successfully created via the Create Order service, verify that the Check Inventory service reflects the reduced stock count for that item, or verify that the order total calculated by the pricing service matches the amount sent to the Payment Gateway service. Or check that the order status displayed on the user's order history page, consumer layer, matches the status stored in the order database accessed via Check Order Statuses service.
Checking the handoffs between services and data consistency.
Got it.
And service level.
And at the service level, we test each individual service in isolation with a range of different inputs, valid and invalid. For the Create Order service, we might have test cases like create order with valid customer ID, invalid customer ID, order with one item, order with multiple items, order quantity exceeding stock. For check order status, we'd test retrieving status for a valid order ID, an invalid ID, an order in processing state, an order in shipped state. For check inventory, test for a valid product ID with stock, valid ID with zero stock, invalid product ID.
Really drilling down on each service's specific logic.
Exactly. Lots of permutations usually.
That gives a really clear picture of the different types of test cases you'd create. Now, how would we actually go about executing these tests in the test execution phase? You mentioned bottom-up.
Right. We generally follow that bottom-up approach. So we'd start with the service level tests. We might use a tool like SOP UI for this.
Okay, using a tool.
Yeah. We'd locate the WSDL or maybe a REST definition and the URL for each service. The tool would likely show us the expected format for the request message. Then, for each service-level test case we wrote, we'd craft the appropriate request data, putting in the valid or invalid IDs, quantities, whatever the test case requires.
Send the request.
Send the request directly to the service endpoint, and then we'd carefully examine the response we get back. Does it match our expected outcome? For instance, for create order, if our test case is to order 1 unit of an in-stock item, we send that request. We expect a successful response, maybe with an HTTP 200 status and a response body containing a new order ID.
And if it's an error case?
If we tried to order, say, 100 units when only 10 are in stock, we'd expect a specific error response, maybe a different HTTP status code, and a message saying insufficient stock. We verify those expected outcomes for every service-level test case.
Okay, thorough check of each service. Then you move up.
Exactly. Then we'd move on to the integration-level tests. Here, we might test through the website's user interface sometimes, but then verify the results by directly checking the database or maybe calling another service.
A mix of UI and back-end checks.
Often, yeah. For example, a tester might go to the website, add a specific product to the cart, and complete the checkout. Then, they'd immediately go into the database and run a query to confirm that a new order record was created with all the correct details, right product, right quantity, right price, right customer.
Yeah.
And maybe query the inventory table to confirm the stock level for that product decreased by 1.
Verifying the database reflects the action.
Exactly. Or if they cancel an order via the website, they'd check the database to make sure the order status field is correctly updated to canceled.
Gotcha. And finally, the end-to-end testing. That's all through the UI.
Mostly, yes. For the end-to-end level, we'd simulate those complete user workflows we defined, primarily using the website or application just like a real user would. So a tester might go through the entire process, browse for products, maybe add multiple different items to their cart, perhaps apply a discount tone, proceed to checkout, enter the shipping address, select a payment method, maybe even add a new credit card, and finally, place the order.
The whole 9 yards.
Pretty much. After completing the order, they wouldn't just stop there. They'd verify the outcome. Did they receive a confirmation email? Does the order show up correctly in their online order history? They're checking that the entire flow works seamlessly without any data issues or unexpected errors from the user's perspective. Essentially, confirming that all those underlying services work together correctly to deliver the required business outcome.
So it's a really systematic way, isn't it? Ensuring each piece works, then checking that they all work together correctly, and finally confirming that the overall experience for the user is what it should be. Seamless.
Precisely. That's the goal. And as, our sources for this discussion highlight, if you have a well-defined strategy, if you have the right resources and the right tools, and you maintain a focus on quality at every single level, service, integration, end-to-end, then SOA testing, despite its complexities, can indeed lead to the delivery of thoroughly tested, robust, and reliable applications.
It's really clear from this whole discussion that understanding SOA, and maybe more importantly, understanding how to effectively test it, is just absolutely essential in today's world. So much relies on these interconnected digital services. They're really the backbone of so much of our online activity.
Absolutely. Couldn't agree more. And, as we continue to move towards an even more interconnected digital future, the Internet of Things, more complex cloud integrations, AI-driven services.
It's only going to get more complex.
Exactly. The importance and probably the intricacies and challenges of SOA testing or API testing more broadly will only continue to grow.
So maybe a final thought for you, our listener, to ponder. How will this increasing interconnectedness of literally everything digital further elevate both the importance and the challenges of testing these services in the future? Think about the implications for data security across countless touchpoints, the absolute necessity for reliability when one service failing could cascade, and of course, the ever-increasing user expectation for a perfectly flawless experience.
Yeah, it's a landscape that definitely requires ongoing vigilance, adaptation, and a really thoughtful, strategic approach to testing to keep everything running smoothly and securely.